Welcome to the notes over Law of Cosines. Now, Law of Cosines is not like Law of Sines, except it is a method of using trig in a non-right triangle. Law of Sines is a way to do that, and so is Law of Cosine. If you look closely at the formulas here, you can see they look very close to Pythagorean theorem, but there's a little bit of an adjustment right at the end there that makes it work for a non-right triangle. You have three different formulas, but you really just have one if you think about it. So the first formula is a squared is equal to b squared plus c squared minus 2bc times the cosine of alpha. Well, let's look at it closely. A, right here, this, whatever this is, it is always the side across from this angle, whatever angle you're taking the cosine of in this formula. The side that you start with is across from it. And then the other two sides are over here, and once you get that it's, you square them plus square them minus 2 times the two sides, you'll get it down pretty quickly. Here, B is across from beta, and C is across from gamma. And so once you get that down, this becomes much, much easier. You don't think of it as three formulas. You just think of it as one formula because you know where everything goes, how it all fits together. All right. You're going to use the law of cosines when you know the measure of two sides and the included angle. So when you have side angle side given in the picture, or you have side 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 given. And these are the two cases where law of sines doesn't work. And it is easier to work out with law of sines. But in these two cases, when law of sines doesn't work, you have to use law of cosines. Let's go ahead and jump in and do an example and see if it makes sense. You have triangle ABC, so I'm just going to draw a triangle. I don't know what it looks like. A, B, and C. It says A is 4. Remember that A is the side across from capital A, so this is 4. Across from capital B is 7. And then we are trying to find, or we also have the 42-degree angle. Now, gamma is going to go with C. All right, and we're going to start by finding the missing side. And I will do law of cosines once, and then I'll start using law of sines to find the other angles, just because I find it easier to do. So let's call this little c. All right, and so whatever we're going to take the cosine of, and since we only have this 42-degree angle, that's what we have to take the cosine of. We start with the side across from it, which is c. So it's c squared equals 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 42 degrees. So again, C is the side across from the 42 degrees. That has to happen. All right, when you have a problem like this, where you have the variable already isolated on the left side by itself, then you can put all of this side. There's no variables over here, so you can put all of that side in the calculator and have the calculator give you a number on it. So I'm going to type 4 squared plus 7 squared minus 2 times 4 times 7 trig cosine of 42 degrees. And I'm just going to hit enter and get an answer. It's going to be a decimal. So I get 23.384. Just going to write that down. So c squared equals 23.384. And then to solve for c, I need to take the square root. So c is going to equal, all right, and I'm just going to do square root. I'm going to go up and grab that number and then enter. And I get I'm going to do 3 decimal places, 4.836. And there's the first missing piece is the side. So 4.836. All right. Now we have to find the missing angles. But because we have this side, we can use it. And I don't like throwing the decimals out there, but that's what we're going to have to do. I'm going to move over here. So I'm going to say the sine of 42 degrees over 4.836 is equal to, okay, let's call this alpha. So I'll say the sine of alpha over 4. We cross multiply. 4 sine of 42 equals 4.836 sine of alpha. Now, when I get you use that 4.836 on the calculator, I'm not going to type in 4.836. I'm going to use the big decimal on the calculator. But I need to divide by 4.836, so that takes care of that, which gives me sine of alpha. But then alpha is going to be the inverse sine, since we're looking for the angle, of 4 sine of 42 over 4.836. Now this is going to be kind of complicated to go up and grab the number, so I'm going to show you what I'm going to do. There is a key on the calculator that will allow us to type, if you look at the negative key, it says ANS, which means answer. So let me show you what we're going to do. We're going to go trig and inverse sine. Then we're going to go control divide to put a fraction. And 4 trig sine 42 over, I'm going to do control negative, which is the very last answer, which is that 4.836. And we get our answer. So I get 33.607. And because we were given, in this problem, originally we were given side, angle, side, there is only one possible triangle that will have that same, any triangle that had the same side, angle, side would be congruent to this triangle, and we would get the same answer. So we do not have an ambiguous case, and when we can use law of cosines, we will never have an ambiguous case because we'll be given side, angle, side. Remember, the ambiguous case for law of sines is what you get when you have angle, side, side given to you in the picture. All right, we just found alpha to be 33.607 degrees, and now we need to find beta. And so the fastest way to do that is to say beta is equal to 180 minus 42 plus 33.607. So we're subtracting those two from 180. So we get our calculator, 180 minus parentheses 42 plus, this time I can go up and grab that, and I'm going to get 104.393. Alright, and that's in degrees. So if I add these three up, I should get 180. So let's just double check it. This plus this plus 42, and there's the 180. Okay. Let's look on the back. Whoops. Okay. In triangle ABC, so let's draw triangle ABC. Gamma is 19.7. I'm working backwards here. Across capital B is 8.8, and A is 12.1, which is across from capital A. And it wants me to find the angles this time. But because I am given side, angle, side, I'm going to use law of cosines, and I've got to find the missing side first before I can find the angles, because I don't have the side across from 19.7. Alright, so we're going to start with, let's call that C again, so C squared equals 8.8 squared plus 12.1 squared minus 2 times 8.8 times 12.1 times the cosine of 19.7 degrees. And then again, because we have C by itself, because we have C by itself, we can go ahead and put everything in the calculator. So we got 8.8 squared plus 12.1 squared minus 2 times 8.8 times 12.1 cosine of 19.7. And I get 23.354. Very close. So C squared is 23.354, and C is going to be the square root of that. So I'll do control, square root, go up and grab the number, and I get 4.833. Okay, very close again. Alright, look at this last problem. The cities of Denver, Oklahoma City, and Albuquerque form the vertices of a triangle. Use the information in the figure and round your answers to the nearest tenth of a degree. What is the measure at the angle of the angle at Albuquerque? So let's put a variable on it. Here's Albuquerque. I'm going to call it theta. And I don't know that I'll work all of these with you, but I wanted you to see some examples you have to solve for the angle because that makes it a little more complicated. Alright, so I know since I need this angle, the only place to put an angle into law of cosines is going to be at where you're taking the cosine. So I'm going to start with the cosine of theta, and then I know that the number that starts has to be across from this, so I'm going to go way back over here and say 509 squared equals. Because theta and 509 are across from each other, that's how it has to be. And that equals 336 squared plus 515 squared minus 2 times 336 times 515 times the cosine of theta. Okay, here's where order of operations is going to make it a little more difficult. You cannot put everything over here in the calculator because you can't subtract right here until you multiply 2 times 336 times 515 times the cosine of theta, and you don't know what theta is, so you can't do it yet. So here's what you have to do. You have to square everything. So we're going to do 509 squared, and the numbers are going to get big. So this is 259,081. Okay, equals 336 squared, which is 112,896, and then plus 515 squared, which is 265,225, minus, now I can go ahead and multiply those together, 2 times 336 times 515, which is 346,080 cosine of theta. Okay, so now you can subtract this off, or you can add these two together because they're not. There's nothing going on with those. So you can say 112,896 plus 265,225 is 378,121 minus 346,080 cosine of theta equals 259,081. I'm going to subtract this, 378,121. Okay, so I'm going to do 259,081 minus this. So I get a negative 119,040, and that equals a negative 346,080. 346,080 cosine of theta. So I need to take the negative 119,000 divided by that. So divided by negative 346,080. Alright, and I'm getting for that 0.34397. equals the cosine of theta. So then I've got to do the inverse because I'm looking for the angle. So theta is going to be the inverse cosine of 0.343967. So I will do trig, go down to the bottom row, inverse cosine, go back up and grab that number. And theta is going to be 69.881 degrees. All right, so that makes it a little more challenging when you have when you're looking for the angle, because you cannot just put the entire right side of the equation into the calculator and get one big number on it, because you have a variable here and you have to follow order of operations. You need to multiply these together first before you subtract. So you have to square your numbers, multiply these together here, that's fine. Subtract, divide, get cosine by itself, and then take the inverse. Alright, I am going to post with these some Khan Academy videos or Khan Academy website pages that might help you. So if you get stuck on any of this, feel free to go to those and look at them. Alright, thank you very much. That's the last set of notes I'm going to give you this week. So you will have these, and then tomorrow you'll probably have some mixed problems going back to sine and cosine together. But I won't give you a whole bunch because they take so much time. All right, thanks, and I will see you Monday when I get back.